Hello everyone, welcome to our lesson on matrices where we will be learning to take a system of equations in 3 variables and we're going to do REF, which is row echelon form, also known as Gauss-Jordan elimination. And we're going to take our matrix and make it into this form where we have our first column as 1, 0, 0. And our second column, we want to get the 1 and the 0 in that form. And then the last one, hopefully we can get a 1 there. So the first thing I'm going to do is, first I'm looking at my system up here. And I can see that the very first row is completely divisible by 4. Really can't reduce the second or the third rows, so even before I start the matrix, I'm going to simplify it. So I'm going to write my first matrix, and I'm going to reduce this by 4. So I'm going to get a 1, a 2, a negative 1, and a 1. The second row is 3, 8, 5, negative 11. And the last row is negative 2, 1, 12, and negative 17. So you can see I'm just using the coefficients. I have my 1 in my very first row, first column. So I'm going to work on getting the 0 in the second row now. And to do that, I'm going to change row 2. That's where I want my 0. And I'm going to add it to negative 3 times row 1. So notation-wise, I'm saying that I'm only changing row 2. That's the only row that's changing. And so I'm going to leave row 1 the way it is. I'm going to leave row 3 the way it is. And I'm going to go about changing row 2 by multiplying row 1 by negative 3. So I'm going to write negative 3 times 1 is negative 3. Negative 3 times 2 is negative 6. Negative 3 times negative 1 is 3. And negative 3 times 1 is negative 3. And I'm going to use those numbers. Notice that this is the matrix. I'm changing it here, so I'm using a new matrix here. Negative 3 plus 3 is 0. Negative 6 plus 8 is 2. 3 plus 5 is 8. And negative 3 minus 11 is negative 14. And so I have done a really good job there. Right away, you know, what catches my eye is that I can divide row 2 by 2. So I'm going to go ahead and do that. I'm going to say row 2 can be 1/2, dividing it by 2, of row 2. And so the only thing I'm changing is row 2. So 1 stays the same. 2 is going to be 0, 1, 4, negative 7. And row 3 is going to remain the same. That's just a little trick to help you simplify the numbers that you're working with. So I'm going to take this matrix and I'm going to move here. I still need to get the 0 down there in row 3. So I'm going to use row 1 again. So I'm going to change row 3 by adding it to row 1. And I'm going to multiply that just by 2. So 2 row 2. What this means is that only row 3 is going to change. So I'm going to copy row 1 and row 2 into my matrix. So that's 1, 2, negative 1, 1. And then 0, 1, 4, negative 7. And then I'm going to do the math in my old matrix over here. So I'm multiplying row 1 by 2. So this will be 2, 4, negative 2, 2, and I'm going to add it to row 3. So 2 minus 2 is 0. 4 plus 1 is 5. Negative 2 plus 12 is 10. And 2 minus 17 is negative 15. And that's super nice. I can see all of those are divisible by 5. So really quickly, I would just write 1/5 row 3 and simplify it. Only row 3 would change. And 5 divided by 5 is 1, 10 divided by 5 is 2, and this would be negative 3. This just helps you work with smaller numbers. It makes it easier. I need a 0 here in my 3rd row in my 2nd column. So I'm going to do that. I'm going to say that I'm going to change row 3. And I'm going to use row 2. I can't use row 1 anymore because that would mess up the zeros. So I'm going to negative row 2, or multiply row 2 by negative 1. So remember, only row 3 is changing. So row 1 would remain the same. Row 2 will remain the same. And if I negative row 2, that'll be a negative 1 here, a negative 4 here, and a positive 7 here. And now I'm going to add them together. So negative 1 plus 1 is 0. 0 plus 0 is 0, that's 0. Negative 4 plus 2 is negative 2. And positive 7 minus 3 is 4. And I'm almost done. I can now see that I can divide row 3 by negative 2. So that would be negative 1/2 row 3. Row 1 is going to remain the same. Row 2 is going to remain the same. And row 3 is now going to be 0, 0, 1, negative 2. And so I have just found my solution here. This gives me, remember that your first column is x, your second one is y, your third one is z, and this is what they equal. So this says that z is equal to negative 2. I can find y now. This would be, if I wrote this as an equation, that would be y plus 4z is equal to negative 7, but I'm going to substitute in the negative 2, so that would be y. 4 times negative 2 is negative 8 equals negative 7, and adding the 8 over, I find that y is equal to 1. And the top one is x plus 2y minus z is equal to 1. Just reading this column here, I'm going to plug in my 1 and my negative 2. So x, 2 times 1 is 2, minus a minus 2 is equal to 1. This is 4, and if I subtract 4 over, I find that x is equal to negative 3. And I have found the solution for Gauss-Jordan elimination, or REF, to be negative 3, 1, negative 2. There are different methods on doing matrices. Sometimes you take a longer way, sometimes you can take a shorter path. It just kind of depends on what you see, but this is kind of the gist of it. So hopefully that helps you in your matrices and your solutions. I'm going to do another quick video with an all solutions problem. Hope you enjoyed this one. Bye.